Hello everyone, welcome you all. In the today's video, we are going to learn one of the very important concept from Unix or Linux, which is piping concept. So first of all, let us try to understand what is piping and what we can achieve by using piping concept. So let me put some points here regarding the piping. So the piping means sometimes we can pass the output of one command as an input for the next command, which is called as a piping. For example, let me execute one command like this. Let's say I have executed one command and this will produce some output for us. So once you produce some output, we can pass the same output as an input to the next command. Let's say command 2. And then we will get the final output. Then we'll get the final output. What does it mean is, whenever we execute a command which will produce some output, and that output we can pass as an input to the next command, then we can get the final output. So this is basically called as piping. So we can pass output of one command as an input for the next command is called piping. So by using piping concept, we can execute multiple commands together. We can execute multiple commands together. So that means one command will give you some output, and that output we are going to pass an input to the next command. That means we are able to execute multiple commands together by using piping concept. So we can use piping using vertical bar. So this is the symbol which we have to use to achieve the piping concept. Now I'll show you a few examples how we can use piping. Let me just write one example here. So let me just print something, let's say ls-l /etc. So what this command will do is ls-l command will display all the files and directories, long listing of files and directories. And then I have provided some directory here. So basically this particular command will display all the files and directories from this particular directory. Let me just execute this command once. Let me connect to my Ubuntu VM. Right, so this is my terminal. So this is my terminal. Let me execute this command ls-l /etc. So this is the command I'm executing, ls-l /etc. So which will display all the files and directories from the etc directory. Let me execute it. Now we got some output here. So where I got the output here, standard output. This is a standard output, means we got the output in the terminal itself, right? So whatever output I'm getting from this command, right, I just want to find out how many lines are displayed here. So once I got the output here, I want to find out how many lines of output we got here as a result. Let me execute once again. So when I execute this command, which will display the some number of files and directories. After that, I want to find how many lines are displayed here. Okay. So then what I can do is I can use one symbol called pipe. And how to find number of lines? We use WC command. And lines, words and characters also we can find. If you want to get only lines, we can say W-L is a command. Now let us try to understand this command. ls-l /etc. This command will display all the files and directories in the standard output device, that is terminal. And that will be passed as an input to the next command. So whatever output you are getting from this command, we are passing that output as an input to the next command. So what this command will do is wc-l will count the number of lines. So whatever output you are getting here, it will just count the number of lines. Now let me execute this command. So clear it. I say ls-l /etc pipe, and then here I'll say WC. Just execute WC, what it will show. So it will show something like this. So this is number of lines, and the second number which is representing number of words and number of characters. And if you want to get only number of lines, we can simply say -el. Now we got only number of lines. Now if I try to understand this command, ls-l /etc, which will display all the files and directories, and that output we are going to send as an input to the next command by using pipe. So what the next command will do, which will take the output of the first command and apply this command wc-l then which will find the number of lines in this particular output. Okay, so the first command will display the output in the standard output device, which is a terminal. Okay, and that will be taking as an input to the next command. Then finally we got the result here. So let me just execute one more command. For example, let's say example 2, ls-l /etc. Okay, now when I execute this command, normally what happens is when I execute only ls-ls/etc, let me first clear this. So ls-l-e/etc. Now it is printed all the files and directories list here, right? But at a time I cannot see, so I want to display all of them page by page. So I want to display the output page by page. So then what I can do is I can just apply the pipe here. So ls-l/etc, which will display all the files and directories. And the output of this command, I'm going to send to one more command called more or less, whatever command you want, you can use. So basically the more command will display the output in the page by page. So for example, this particular command will send the all the files and directories list, and the more command will show that output page by page. So what is the input of this more command is the output of the first command will become the input of the next command. So that can be achieved by using piping concept. Let me execute this. When I say enter, now it is displayed the first page. Now when I say space bar, then it will display the second page. Now third page, fourth page, fifth page, sixth page, 7, 8, 9, 10, 11, 12. So totally 12 pages of data which is displayed. So what this command will do is ls-l/etc, which will display all the files and directories, and that output I am passing to another command called more, which will display the data in page format, page by page data. Okay, this is one more example. Let me show you one more example. Let's say example 3. So ls-l/etc, so which will display all the files and directories from etc directory. Then I want to display top 5 lines. For example, let me just clear this. I'm executing the same command. When I execute this, how many lines which is displayed? Totally so many lines are there, but I want to display only top 5 lines. Top 5 lines I want to display from this output. So how we can write the command top 5 I want to display? So I can write one more command, pipe. We can use head command, right? Head-5. Now what this command will do is the first command will display all the files and directories, and that output is going as an input to the next command. So in the what is the next command? Head command will take the input from the first command and find out the first 5 lines and will display as an output. So let me execute this command. Clear ls-l/etc pipe. I say head-5. So now we can see only the 5 lines are displayed, including the first line. 1, 2, 3, 4, 5 lines are displayed. So the first command will display all the files and directories, and that is an output we are getting from the first command. And the same output we are going to send as an input to the next command, that is head-5. So this will display the first 5 lines of the output. So we can achieve this piping. So the input of the first command will be sending as the output of the first command will be sending as a input of the next command. So the output of the first command will become the input of the second command. Okay. So these are all few examples. So now let me show you one example. Let's say I have example 4. Okay, in example 4. So in this, what I'm going to do is say ls-, this is a command I'm executing, ls-l again as etc, and which will display all the files and directories. I just want to count number of lines, number of words, and number of characters. Simply what I can do, we can use wc command. So what wc will do is whatever the output we are getting from this command, wc will just count the number of lines, number of words, and number of characters. So let us try to execute this. So let's try to execute this command. So which is displayed this output. So ls-l/etc displayed some output, all the files and directories, and that output is going as an input to the next command, which is wc. And what wc will do, which will find the number of lines, number of words, number of characters. We got the output. Now again, I want to pass this output to the next command. Let me write like this. So I'll say wc pipe, and I'll say wc -l. Now what is an output of this command? So let us try to understand. The first command will display all the files and directories, and that will go as a input to the second command wc, which will return the output like this. So number of lines, number of words, number of characters. So only one line which is written, which contains a number of lines, number of words, number of characters. And on top of this output, we again applied one more command, wc-l. So whatever output we are getting here, on top of this output, we applied wc-l. So what is wc-l will do? Which will find the number of lines. So how many lines we have here? Only one line. So the final output will be 1. So the first command will return all the files and directories, which will send as a input to the next command, which will find number of lines, number of words, and number of characters. And that is again going as an input to the next command, which will find the number of lines, which is 1. Okay. So this is how we can just use piping concept. So what is piping means? The output of one command we can pass as an input for the next command. And in the piping, we can use multiple commands together, and we can achieve piping by using a vertical bar. Okay, so these are few examples. So now let me show you one more example. And if I just look at these examples, in every example, the first command whatever executed, basically this particular command will return a standard output, right, in the terminal itself. And that output we are using as an input to the next command. We are using that output as a input for the next command. Okay, remember this. Now let me just give you one more example. Let's say example 4. Okay, so this is example 5. So in example 5, my requirement is, let me write my requirement here. So this is my requirement. So the output of ls command should be saved to output.txt file. This is my first requirement. So the output of ls command should be saved to output.txt file and should be provided as input to the wc command. So let us try to understand this requirement once again. The output of ls command should be saved to output.txt file. This is one requirement. So the output of ls command should be saved to output.txt file, and the same output of ls command should be provided as an input to the wc command. Okay, so what I'm going to tell here is, there is ls command. So whatever ls command we will execute, this is my ls command. So once ls command executed, we will get some output. So we'll get some output, right? So once you get the output, I'm going to use this output. I'm going to write this output into output.txt file. Okay, I'm going to write the output into output.txt file. Let's say output.txt file. I want to write the same output, and the same output I want to send as an input to the wc command. So this is my requirement. So whatever ls command I'll execute, whatever output we are getting from the ls command, the same output will be written in output.txt. So the output of ls command should be saved in output.txt. The same output come here, output.txt, and whatever output you are getting from ls command should be provided as an input to the wc command. So this is something, a different type of requirement. Now we will see how we can achieve this. Okay, so normally when I write like this, let me write some example here and then we will understand. So let me write like this. First requirement is what? The output of ls command should be saved in output.txt. So what it is basically it is doing, what is basically talking here is redirection. So the output of ls command should be saved to output.txt. So normally what you will do, ls-l, this will give you, or ls-/etc. So whatever the files and directories we have in etc will be displayed. So the output of this command should be saved to output.txt. That means we can use redirection symbol, right? So I'll say output.txt. So this command achieved the first requirement. So the output of the ls command should be saved to output.txt. This is the first requirement, right? And after that, what I'm saying, and the same output, whatever output you are getting from this command, should be provided as an input to the wc command. Input to the wc command. Okay, input to the wc command. So we have to write another command by using pipe. Let me write like this. All right, so now let us try to understand this command. What exactly we are doing here is, whatever output we are getting from this command, I'm writing the output into output.txt file. I'm saving the data in output.txt file by using redirection. After saving the data in output.txt, do we get any output for this? There is no output, right? So after executing this particular command, there is no output, because whatever output we are getting from the first command, we are writing or we are saving the data into output.txt. That's it, but we are not getting any output there. So wc will not have any input now, because this command, pipe command or direction command, what this exactly doing is, it is basically breaking the piping concept. That means whatever output you are getting here, we just saved that output in output.txt. That's it. We are not getting any output out of this whole command, because once you get the output from this whole command, then we can pass that output as an input to the next wc command. But here we are not getting any output, so that wc doesn't have any input for that. So that is the reason this command cannot achieve this requirement. So the output of ls command should be saved in output.txt. This will work, but wc doesn't have any input for that, so which will not give you, wc command will not execute, because wc command doesn't have any input for that. Okay, let me try to execute and see what is an error we will get. Let me just copy it and connect to Ubuntu. Just a moment. Just a moment. Let me connect to my Ubuntu. Okay. Now it is connected. So now let me execute this command. So I say paste. So ls-l/etc. These are for my first command, and whatever output you are getting from this command will save into output.txt. That's it. So here it is gets stopped. So there is no output of this command, right? So if there is no output of this command, we don't have an input for the next command, right? So let me execute this. What happens? It is a 0 0 0. Why it is 0 0 0? Because after executing this command, there is no input for the wc. If there is no input means what? No lines, no words, and no character. So 0 0 0 is giving. So this is not fulfilled our requirement now. Okay, so this is not fulfill our requirement now. So let me just modify the case now. Just a moment. Okay, so now let me just modify the command slightly. So instead of doing that, let me write something like this. So here the problem is in the middle of piping. Okay, so here the problem is in the middle of piping. If I use redirection, then it breaks the piping, because we are not getting any output from this command. Because once you get the output, we can pass that as an input to the next command. But here we don't get any output for this command. So the piping, the middle of the piping, if I use redirection, then it breaks the piping concept. So then how we can achieve this? So what is our requirement? Whatever the output we are getting from this command, we have to save the output in output.txt, and also on the same output, I want to execute wc command. Okay, this is something called, we have to pass the input for the two commands. We have to pass the input to the two commands. Now let me show you again. So here we are getting the output. So ls output we are getting. First we have to save the output in output.txt file. Output.txt file. There's a first requirement. And the same output we have to send to the wc command. And if I just look at here, there is something called, it seems like a T, all right? It's something called T junction. That means what? Whatever output we are getting from the ls, we are sending the output to the output.txt, and also same output we have to send to the another command. So how we can achieve this? So to achieve this kind of requirement, we have to use something called T command, because it seems T junction, right? So we have to use a T command. So what the T command will do is, whatever output we are getting from the ls, we will save the output in the output.txt. After that, the same output we can send to the another command. That can be achieved by using T command. Okay, now let me show you how we can use a T command. So the same command I can write like this by using a T command. T command, which is very, very useful command we can use along with the piping concept. So we can use a T command. So here we have to write command like this: ls -l/etc, which will give you all the files and directories. And what's the first task we have to do? We have to save that into output.txt. Okay, so let's say use pipe here, and here I'm using T command. T output.txt and then wc. So let us try to understand this command. ls-l/etc. This command will display all the files and directories, and that output is become the input of the output.txt and wc. So how T command works here is, whatever output you are getting from this command, the output first saved in output.txt. Okay, so what T command will do is, whatever output you are getting from the first command will be saved into output.txt. After that, the same T command will send the output of the first command, or which will forward the output of the first command to the next command, that is wc. So that means what? The first thing is, the output of this command will be saved into output.txt file. That is done by the T command. Now after that, the same output of the first command will forward it to the next command. That is also done by the T command itself. Okay, now whenever you find this kind of requirement, we can use T command along with the pipe symbol. So what the T command will do is, whatever output we are getting from this command, we can pass the same output as an input to the next commands or multiple commands. And basically T command will save the data in file. After that, it will forward the same output to the next command. Okay, T command will save the data in first file, that's the first activity. After that, it will forward the same data to the next command. So that is a use of T command. Now let me just show you few examples how we can use T command. So let me just execute the same command now. Go to the terminal, clear. I'm just executing this command, ls-l/etc. The output of this command will be saved in output.txt, and the T command will forward the same output to the wc. Now execute. Now we got the output. So 222 lines are there in the output, and 2005 number of words, and this many number of characters we have in this output. And the same data will be saved in output.txt also, right? This is the output which is producing by wc command. But what about output.txt? The output of the first command will be saved in output.txt and then forward the same output to the wc. So wc command will give some output here. But what about output.txt? Let me print that. So cat output.txt. So now we got the data. So this is the data which I have copied into output.txt. So this is the data which is copied in output.txt. Okay, so this is how we can use T command, okay, along with pipe. Let me show you one more example. Okay, let me show you one more example. Here, the same command I'm writing like this. ls-n/etc pipe symbol t output.txt. I'm just removing wc. Then what happens? So this command will print all the files and directories. And what t command will do, which will write or save the result into output.txt. After that, do we have any command? No command. So just it will not return anything for us. It will just write or save the data of the first command into this output.txt. That's it. Let me just execute this command. Clear. And before that, I'm just removing output.txt. Okay, I just removed. Now execute this command. Paste. So ls-ls/etc. Whatever output you are getting from this command will be saved into output.txt. So t command will do that. After saving it, the t command will forward the output to the next command. But do we have any next command here? We don't have any next command. So simply it is display the output here. Let me execute one more time. So here we don't have any next command. Just a second. Let me write once again. ls-l/etc pipe t and output.txt. Okay, so what exactly it will do is whatever output you are getting from this will be saved into output.txt. After saving, do we have any other command? So after saving, t command will forward the output to the next command, but we don't have any next command here. So what happened to the forwarded output, which will just display in the terminal. So let me repeat once again. The first command will repeat the files and directories, list of files and directories, and those files and directories will be saved in output.txt by using t command. After saving it, then it will forward the same output to the next command, but next command is not there. So what happened to the forwarded output? Then what will happen to the forwarded output? There is no command here. There is no next command. So simply whatever output is forwarded by the t command will just display in the terminal window like this. So now two things it has done. One thing is it is just copied the output in output.txt and also display the output in the terminal window. Okay, it is just copied the output to the output.txt and also display the output in the terminal window. So two things we have achieved this. So this is a one more example by using t command. Okay, this is, let me just say this is example 6. So the output of ls command should be saved to output.txt file and should be displayed. So we don't have any further command. So the t command will just display the output in output.txt, but there is no other command. So it just display the output in the terminal. So this is how we can use t command along with piping. Now let me show you one more requirement. Let us say example 7. Example 7. So let us have this kind of requirement. So test.txt contains some file names, and we have to read all the file names from this particular file and remove each file. Okay, what is my requirement here is, let me just draw something here. So I have one small file. Let us say this is my test.txt file, which contains, let's say, test1 and test2, test3, and so on. So multiple file names are there, multiple file names. And also I have these files physically. Okay, test1, test2, test3. I have created multiple files in my directory. And I also have another file called, let's say, test.txt, which contains multiple file names. So whatever files I already created in my directory, the same file names are available in this particular file. My requirement is, I just want to read these file names from this particular file, and whatever file name I'm reading from this file, I just go and remove the particular file from the directory. Okay, so let us say I have 100 files like this, test1, test2, test3, let's say test 100. But in this particular file, I'll mention test1, test2, test3, test4, and test5. Then I want to read whatever file names I mentioned in this file. I want to just read those file names. Accordingly, I just remove the files physically from the drive. Okay, this is my requirement. So let's see how we can achieve this requirement by using piping concept. So let me repeat again the same requirement. So I have a single file which contains only file names, and these files also available in the same drive. So whenever I execute one command, single command, I have to do all these things. So whenever I execute a command which will read all the file names from the file, accordingly which will remove the files from the same directory, and whatever file names are mentioned in the file, all the files will be removed. Like let's have 100 files. Now here mentioned only 5 file names, and only those files should be removed from the directory. Okay, this is my requirement. Now let us see how we can achieve this. Very important. So test.txt contains some file name. Let me just create some files here. First of all, clear. Let me just clear it. So let me just create some files. So how to create multiple files is we can have a command called touch command. By using this, we can create multiple files at a time. So let's say test touch command test1, test2, test3, and test4 and test5. So let's create 5 files. So touch command will create multiple files at the same time. And let me just list out here. Okay, let's say ls-l, which will display all the files: test1, test2, test3, test4, test5. So 5 files are created. And apart from this, I will also create one more file called let me just create test.txt file. Okay, so let me just create. I use getEdit command. So gedit test, or I can say test.txt, and inside this I'm just specifying all the files whatever I created. So totally 5 files are created, test1 to test5. So here I'll say test1, test2, and test3, and then save the file. Now if I just look at this, clear. When I say ls, I have test1 file, test2, and test3, 4, and 5. So totally 5 files are created. Now if I just look at this tests.txt, which contains a 3 file only. Now my requirement is I want to read this data from the test.txt file, and whatever file names I mentioned here, I just want to remove those files from the directory. Let's say test1, 2, 3 I mentioned. So 1, 2, 3 should be removed from the directory. Okay, this is my requirement which we have to achieve by using piping concept. So how we can do that? Let me just write a few commands here. Let me just first I want to get the files from this particular file. So how we will get? By using cat command. So cat test.txt. Let me write commands like this. So let me write like this. So first command I'm writing like this: cat test.txt. So what this will return? Basically, which will return standard output, right? So return standard output in the terminal. So what is the standard output? Which will basically display the files. So whatever content we have in the file will be displayed. Okay, this display the standard output. Now, if we want to remove all the files, so read file names from the test.txt and remove each file. So how many files I mentioned in the test.txt? 3 files: test1, test2, test3. I want to remove them. So to remove the files, what is the command we will write? Rm test1, test2, test3. So like this we can write. So what this command will do, which will remove, this particular command will remove 3 files, right? So these are the 2 commands we can use. Now I have to combine this. The first command is just will display the content of the file. So just display the whatever file names we have in this test.txt. So what it contains now? It contains a file1, or which contains a test1 file, test1, test2, test3, right? These are the file names we mentioned in the test.txt. And after reading these file names, I just use remove command. And remove command, by using remove command, I just want to delete these files. I want to delete these files. So how we can achieve this? And when I use piping concept, observe this very carefully. When I use piping concept, I'll say command 1, piping, command 2, like this we use, right? So normally what happens? the output of the first command will become the input for the next command. Then we will get the final output. Then we'll get the final output. So this is the concept of piping, right? Now, when the second command will take the input from the first command, so the first command will return some output, and that output will become the input of the next command, that is command 1. Then finally we will get the output. So in the piping concept, if the first command returns a stream, so stream is nothing but it is not standard output. It should not be any standard output. So but here, if I just look at here, test.txt, what this command will do, which will return a standard output in the terminal. Let's say test1, test2, test3. But what about the RM? RM needs some arguments like this. RM command will need some arguments. So when I write the command like this, I'll say cat test.txt pipe RM. When I write like this, what happens is the first command will display the file names which are present in this particular file. But what is our intention here? RM command should remove the files. Whatever file names we mentioned in the first file should be removed by RM. But if I just look at this command, the first command will display the output in the standard device, that is terminal. Let's say file1 or test1, test2, test3. But RM requires parameters or arguments. So in this context, RM cannot read the data from this output, from the first command output. Why? Because the first command will provide the output in the form of standard output. So test1, test2, test3. But RM requires parameters. Okay, if I just look at our previous examples, the first command displays some data, and that data will be, this command will be applied on that particular data. But the wc-l doesn't require any arguments here. So whatever output you are getting from this, the second command will execute on top of the output. Okay, but wc command doesn't require any parameter here. But whatever output is returning from the first command will become the input of the second command. It doesn't require any arguments. Only the output of the first command will become an input of the second command. But in this particular case, the output of the first command cannot become the input of the second command, because the output of the first command is just print the standard output. But RM needs some arguments. If I just look at this command, RM requires some parameters or arguments. But here, from where RM get the parameters? But it is just giving the standard output. Let's say test1, test2, test3. But I want to pass these three as an arguments to the RM, and then only it will work. Okay. So suppose when I say RM test1, test2, test3. Suppose if I have 3 files I mentioned like this. If you have more number of names in the test.txt, there are so many names are there. How we can achieve this? So RM require the parameters. But here the first command just display the output. From that output, test1, test2, test3, we have to pass these 3 file names as an input, as an argument to the RM. So to achieve this kind of requirement, we have a special command called Xargs. So we have a special command called Xargs. Let me just explain this. So by using this command, we can achieve this. So whatever output we are getting from the first command, if you want to pass that output as an arguments of the second command, then we use xarg command. So let me just write this command like this. I say cat test.txt. Okay, and here I'll say xargs rm. Okay, xargs rm. So now how this command works is, so the first command will display the standard output, test1, test3, test3. But RM command cannot take the standard output. It needs some kind of a stream. So whatever standard output we are getting from the first command will be converted into stream, will be converted as an arguments by using xargs command. So xargs command will convert the output of the first command as an argument of the second command. Okay, the output of the first command will become the arguments of the second command, that is rm, because rm is required arguments. Rm requires some arguments, and those arguments are the basically input of the first command. So when I execute this command, this will fulfill the requirement. So test.txt contains some file names, and read file names from test.txt and remove the corresponding files. Let me just execute this command. Let me just execute this command. Let me open my Ubuntu. Yes, now clear this. I'm executing this command. So cat test.txt, which contains only 3 files I mentioned: test1, test2, test3. Okay, let me just print once again. So I'll say cat test.txt. We have only test1, test2, test3. But in ls, we have 5 files: test1, test2, test3, 4, and 5. I want to just remove test1, test2, test3 because I have only 3 file names in the test.txt. So I can write command like this. I can say, first we need to get the file name from the file. I'll say cat test.txt. So this will give you a file names. After that, I use pipe symbol. Then I'm using Xargs command. So what this command will do, whatever output you are getting from the first command will pass that output as an arguments of the second command. What I'm saying, why I'm saying arguments here, because rm requires the arguments here, and whichever file name you specified, that file will be removed. So whatever output we are getting from the first file, whatever file names we mentioned in the test.txt will be sending as an arguments to the second command, that is rm. Now when I execute this command, which is done, now when I execute ls command, you don't see test1, test2, test3. So you can see test4 and test5, but you cannot find test1, test2, test3 because those 3 files have already removed by this command. Okay, so this is a very important scenario. So xars also a command which we can use along with the piping concept. So xarg is another command which we can use along with the piping concept. Okay, so whatever output we are getting from the first command, if we want to pass that output as arguments to the second command, then we can use xars. Basically this will convert the standard output to the stream, because the rm command requires only stream. So pipe works only with the streams, not the standard output or standard input. Okay, now let me just show you one more example, then you can understand this. So I want to example 7. So I'm just going to show you one more example. Let's say example 8. So display the output of the date command by using echo command with the piping concept. So normally how we will display the date, we say date command. So we'll say date command will display the date. But I want to display the date by using echo command. Okay, what echo will do is, when I say echo, in the double quotation, whatever we see, whatever print, okay, that will printed in the terminal window. So this is the purpose of echo command. But my requirement is I want to display the output of the date command in terminal by using echo command. So what I have to do, we have to send the output of the date command as an input to the echo command. Okay, as an input to the echo command. So what does that mean? When I execute the date, which will just display the standard output, but echo command is required argument. So echo command is required some arguments. Here the message itself is an argument. So how we can pass the output of the first command as an argument of the second command? We can write like this: date pipe, right, xargs echo. Okay, now what happens? The date command will display the date. That is a standard output. And if you want to pass that output as an argument for the next command, that is echo, then we can use args, because echo required argument. Echo required argument, just like a remove. So rm is also required argument here. Okay, so that's the reason we are using AR. So whatever output we are getting from the first command, we are passing that output as arguments of the second command. Similarly here, whatever output we are getting from the date, we are passing that output as arguments of the second command, which is echo. So when I execute this command, which will display the current date. When I paste here, which will display. So whatever output we are getting from the date, we are passing that output as an argument of echo command. Okay, argument of echo command. So this will display, right? So this is how we can use Xarg, T and Xarg. So three things we have learned. So what is piping? So basically piping means the output of the one command become input of the next command, which is called as a piping. And in the piping, we can execute multiple commands together. And we use vertical bar to achieve piping concept. And sometimes if you want to pass the output, or if you want to forward the output to the next commands, then we can use a T option or T command. And what T command will do is first the output will be saved in the file, then it will forward the output to the next commands. In that case, we use T command along with the pipe. There is one more command called Xargs. Sometimes few number of commands will display the output, but I want to use that output as an argument of the second command, arguments of the second command. And that case we use Xargs option. This is a command, not an option. So whatever output you are getting from the first command, we are passing that output as a argument of the second command. Okay, so in that case we use Xargs. So these are our very, very important options which we have in the piping concept. Okay, so that's all for this video, guys. Thanks for watching.